So in Algebra 2 with trig, we're working with 13.2. We're going to talk about our general angles and radian measures. We're going to talk about degree values and radian measures. There's a few things that we'll need to be able to do. Our I can statements are to be able to draw an angle in standard position. You're used to drawing a polygon in standard position. That'd be a vertex at the origin and a side along the x-axis. Then you had your other points along the, typically the first quadrant. Well, we're going to do an angle with very much the same characteristics. You're going to need to talk about a positive and a negative coterminal angle. All right, so you're going to look for those words, and we're going to talk about a positive and negative coterminal. And you'll also work with converting angles. I'm not a big fan with converting angles. I think you should learn to understand what the angle means in radian, but there are often times when that is necessary. So when we talk about an angle in standard position, on the coordinate plane, an angle can be formed by a fixed ray called the initial side. And rotating the other ray called the terminal side. So one side is going to stay right where it's at, and that's the initial one that's going to stay along the x-axis. And then we're going to rotate around this terminal side, and that's going to make angles less than 90, greater than 90, greater than 180, even greater than 360. An angle in standard position or is in standard position if its vertex is at the origin and its initial side is on the positive x-axis. So just like we had standard position for polygons, like I mentioned, it's the same kind of definition for an angle. So a positive angle, if we're going to have an initial side on the x-axis, a positive angle will be heading upwards. That will give you a positive measurement. So that would perhaps be close to 60 degrees there, going up in a positive. A negative angle would still have the terminal side along the x-axis, but a negative angle is going to head downwards. That might be drawn at like a negative 45 degrees, halfway between 0 and negative 90, which would be straight down. So we're going to practice drawing out a few of these. Okay, we're going to draw an angle with the given measure. We have 135 degrees. Well, we know that 90 degrees is straight up. If this is 0 over on the side, we know 90 is straight up. We know 180 is all the way to the left side. So 135 actually falls exactly in between 90 and 180. It is 45 degrees past the 90 is the 135. And that would be your 135 degree angle. So notice kind of how we did that. We thought about where the 90 was. We knew it was more than that. We know it's less than 180. And starting to recognize how much past 90 helps you give a good approximation of where the angle would be. 640. That's a crazy angle. Well, we know 360 degrees is all the way around. 90 more degrees, so that's 360. 90 more degrees would be 450. 90 more degrees would be 540. 90 more degrees would be 630. And we want to get out to 640. So that's going to be past a full loop and from pointing downwards. Okay, 10 extra degrees past the 630 will give you your 640. So those are both positive angles because we went in a counterclockwise direction. So now we're going to go in a clockwise direction, and those are going to be negative angles. So you could still, you don't have to draw this terminal side, or the initial side actually. You do need to draw the terminal, that's where the angle is pointing. But we have our angle at 0, so that's my focus there. But we come down and we're at negative 100. Oh, sorry, negative 90 is straight down. So with 15 more degrees, we would be at negative 105. That would be that value here. And then in the future, we're going to be able to graph an angle that looks like that. 7 pi over 9. That is in a different language. That is in called radian mode, or not mode, but it's in a radian measure. Rather than degree measure, it's radian. It's kind of like feet and inches or centimeters being a different way to measure. Radian is just a different way to measure. We have coterminal. Those are angles whose terminal side coincides. So two angles that might point in the exact same direction. They can be found by adding or subtracting multiples of 360 from an angle. So if we're looking for one positive and one negative coterminal angle, what angles point in this direction is what's being asked. Well, maybe it would be good if we started out with a visual of what does that even mean? Where is 215? 215 is more than negative 80. Right? Negative 80 would be pointing off to the left, all the way around. So then we have 20 more degrees to get to 200 and 15 more degrees to get to 215. So it's about 35 degrees more than the negative 180. That would be your negative 215. So what else points in the exact same direction? Well, if you go negative 215 and you continue in another full circle, so that's another negative 360 to that, you would get negative 360, negative 215. That is 575 would be a coterminal that was negative. So by doing another full circle all the way around, that would be a negative 575 degrees. So that's 360 more degrees, right? That's a full circle, points in the same direction. Now to find the positive coterminal, there's different ways to do this. You could focus with the 180, right? Didn't we decide that we went 35 degrees more past the 180? Okay, we kind of talked about that. We went 20 to get up to 200, and then we went 35 to get up to 215. So we went 35 more degrees. So you could do 180 minus 35. That'll be the exact answer. But probably more common is to think about ourselves pointing in that direction and then start to go in a positive 360 all the way right back to where it was. Kind of unwind your spring. So if you have 360, we typically like to put our larger number on top. So it gets a little confusing having your value on bottom. I wouldn't say that you're subtracting 215 from 360, but you're adding 360 to the negative 215. So that gives us 145. Another way with your calculator, right? You have your negative 215. That's the direction you're currently pointing. And now you want to get a positive angle out of this. So you're going to add 360. You do multiples of 360. And that's where the 145 comes from. So you want to show something in your work. So that's why I did 360 and I added, that was a positive 360. And I guess I subtracted the 215. Because you want to put your smaller number underneath so you can carry your values correctly and all that. Okay, let's talk about 570. Where would 570 be? Well, 90 degrees is straight up. 360 degrees is off to the side. 450 degrees is also straight up. 90 more degrees is 540 degrees, is straight to the left. That's 540. So we have to go 30 degrees past that. So we kind of went around and all the way back to get to that position. That would be your 570 degrees. Well, you can get another number by adding 360 to that. But you can also get another positive answer by just subtracting 360 from that. All right, I got my number in there backwards. All right, it's not 540, it's 570. That would be 210. Okay, so 210 is the same location by unwinding 360 degrees. So you're still pointing in the same direction. Now, if you unwind that again and go another full 360 around, so it's really you're undoing the 360 from the 210. You're going in a negative 150. Isn't that 30 more than the 180 we decided to get to the, let's see, 540 came all the way to here. We went 30 extra degrees to get to the 570. So it's 30 degrees in here. We're going to call that a reference angle in the future. So this is 30 degrees, not quite half the circle. So 30 degrees less than half the circle is 150. 30 degrees less than 180, half the circle. So I subtracted, maybe it would make more sense to you to think about 570 and you're taking 360 away, and you're taking 360 away, and you come up with a negative 150. All right? So you're doing multiples of these 360s. You're adding or subtracting 360 to it multiple times. We need a positive answer and we need a negative answer that points in the same direction. We can also do this in radian. We haven't learned the radians yet, so when we do, we can always come back and try that. So you go ahead and try to draw out these three angles. You can probably hold on to the radian version of it, but you can pause the video and come back and check your answers. 65 degrees. Well, we know 90 is straight up. 45 would be half of that. So 65 is going to be in between those two. So there is your 65-degree angle. Negative 130. Well, negative 90 is straight down. Negative 180 is all the way to the side. Halfway between that is negative 135. So 130 is going to be a little bit short of that. We don't know about the radians yet. 740. Well, it's 360 to get all the way around. And it's 360 again, which is 720 to get all the way to there. So 740 is going to be 20 extra degrees. So if it's 20 extra degrees, then you know that that is a positive coterminal. It's 20 degrees. It's 20 degrees extra past two full circles. So we're going to take our 740 and we'll minus 360 from that. We got 380. That's a positive coterminal. We minus 360 from that. And that's a positive coterminal. That's probably the better one to talk about. Okay, we usually like them within one circle, 360 degrees of 0. So that's a good answer. And then we're going to go 360 degrees past that. So starting out in this direction, if you go in a negative direction, down and around, you would get to 0, and then you would go all the way around 360 degrees, not counting that 20. So you can figure that the answer would be 20 degrees less than 360. So we're going in a negative direction. So that's why I write the negative 360 first, because it's the bigger number. It helps to do all your carrying. But the larger number is negative, so that's why you have a minus on the 340. That's a negative coterminal. If it would help you to do it with the calculator, you've got the 740, and we subtracted the 360. We subtracted the 360, and we subtracted the 360, and we finally came up with negative 340. Now we finally get to talk about this new language, this radian. What is a radian? It's another way to measure an angle, just like feet or inches are different ways of measuring a distance. Yards is different than feet. Centimeters, meters, those are all just different measurements. A radian is just a different measurement for measuring an angle. A radian is a measure of an angle in standard position whose terminal side intercepts an arc length of a radius. So if we take a circle and we have our radius on there, and then this isn't perfect, but it can work. If we measure what that radius is, okay, so that's approximately the radius. I'm going to measure that distance along the circle is about right there. All right, that's not awesome, but that kind of works. Gives you the idea of what's happening. So that would be considered 1 radian. Not 1 degree, 1 radian. So if we come over, since I lost my measurement, and that was 1 radian, this comes out to be 2 radian. If we do it a 3rd time, we come out to be about here. And let's see how that, if you go straight across, I came out just short of straight across. Anybody have a guess how much short I came up? If this is 1 radian and this is 2 radians and this is 3 radians, this little bit is 0.14. Isn't the diameter, doesn't it go around a circle 3.14 times? Isn't that what pi is? It's the number of diameters that fit around a circle. Yeah. So the number of radiuses that fit around half a circle is going to be 3.14. Because a radius is half the diameter and it fits around half a circle, the same amount. Twice the radius would fit around twice the half, the full circle. So what we're learning about here is that because the circumference of a circle is 2 pi r, we know that there are 2 pi radians in a full circle. So if I would continue this, I got my 3 to be approximately there. If I would continue, that was my 3, and then I would do my 4, and I would do my 5, and I would do my 6. So how many radians fit around a full circle? Two pi. Other people might call it, well, if this was 3.14, then this is going to be 6.28, right? That's how many radian. But you're more exact as saying 2 pi. It's 1 pi to be half the circle. It's going to be 2 pi to be full around the circle. So what do you think if we only went that far? How far, what amount of pi would be facing straight up? We're not doubling pi to point straight up, right? What amount of the pi, if we're going to take, call it pi to come all the way over here, what if we only go to there? How much of the pi was that? That was half the pi. So we call that pi over 2. So instead of calling it 90, why is that 90? Because it's half of 180. But we're not going to use the 180 word anymore. We're going to take half a pi. So that divides the pi into a half. And eventually, we're going to come through and talk about 3 angles in every quadrant. We're going to talk about all 3 of those in each quadrant, plus what we call a quadrantal angle, plus the ones on the very end. What would be our measurement down here? If that is 1/2 a pi, and this is 2 halves of pi, what would be another half? 1/2, 2 halves, 3 halves, 3 pi over 2. It helps if you can count in the units. So we're counting by halves. So 1/2, 2 halves, 3 halves. 2 halves is the same as 1. Okay, degree measures and radian measures are therefore related, as 360 degrees is the same thing as 2 pi. You could divide by 2 on each of those, and we would say that 180 is 1 pi. Those are equivalent to each other. So to convert degrees to radian, if we have a degree value, 90, and we're going to convert this over, when we do a conversion, we look at a ratio, and that ratio has to be a value of 1. It's like saying you have 60 inches. How many feet is that? Well, if you want feet, you're going to put 1 foot on top and you're going to put 12 inches on bottom. Isn't that your conversion factor? If you're working with inches, the inches would be on top and bottom and they cross out. So 12 goes into 60 5 times and you're left with the units of feet. So there are 5 feet. You use that conversion factor. Well, here with radian, you know that 180 and the pi I wrote it upside down. The 180 and the pi are the same amount. They're the same unit, like 1 foot is 12 inches. That's a value of 1. This is a value of 1. You want the 180 on bottom because you want the degrees to be able to cross off, and you're left with pi reduce. So you get pi over 2. And that's what we've already talked about 90 degrees was. So when you convert a degree into radian, you're going to be using pi over 180. When you want the degrees to cross off, you put the degrees on bottom. Or when you want to have a radian answer, you want the pi on top. However you want to think about that. And then you're going to have the reciprocal over here. You're going to have 180 divided by pi. If you want to turn radian into degree. If you want to take a radian, so pi over 4, what is pi over 4? If you take this pi and you break it into 4 equal amounts, what is each one of those going to be? You would want your pi's to cross out. And now you have 180 into 4 equal pieces. That's 45 a piece. So 45 is converting your pi over 4 into a degree. Now, as we practice that, it's a bad habit to convert everything. You do not want to convert all your math that we're going to do in the future in radians. You do not want to convert. There are a few that you need to. Like 75 degrees. We need to convert 75 degrees because 75 degrees is not found on the unit circle. So we're going to take our 75. We want to convert it into radians. So we want the pi on top and the degrees on bottom. So the degrees can cross off. All right, and we can reduce these. We see that 15 goes into 75. All right, we have our 75. We're looking for a value that goes into both of those. So I'm feeling that 15 is going to go into both of those. And we're getting 5 pi over 12. That is not a common spot on the unit circle. Thirds, sixths, and fours are common values. Also twos. Okay, here's a 4. We could actually figure this out on the unit circle. If 1/4 was 45 degrees, we're going 1/4, 2/4, 3/4, 4/4, 5/4 is going to be pointing in that direction. But right now we're learning about the conversion. I'm not a big fan about it, but we can do it in this format. We want to do this type of answer without a conversion factor. Okay, 4 goes into that 45 times. Okay, and we get negative 215. Or 25, 225, sorry about that. Okay, 135. Well, 135, and we're going to use our pi on top because we want it to turn into radians. So you want the pi left over. Okay, then you start to reduce this. We know that 45 goes into 135 3 times, and 45 goes into 180. So if you think about the unit circle, you would have 1/4, 2/4, 3/4, and that's why it's pointing off in that direction at 135. Okay, so we have 17 pi over 6. And we're going to say 180 divided by pi, because you want the pi on bottom to cross off with the pi. So you're left with just degrees. So 6 goes into 180 30 times. And we've got, I believe it's 510. There it is. 30 times 17 is 510. So we have used a conversion factor to convert these over. So you can go ahead and try the next two. So we take our negative 50. And so this is degrees. We want the degrees to cross off. So I'm going to put a degree value on bottom, which is the 180. I'm going to put the radian version on top. Those are both the same amount. We're multiplying by a value of 1. So we know that 2 goes into 50. That would give us negative 25. We know that 2 goes into 180. That would give us 90. But it looks like we can still reduce that further, right? So maybe we could have done 10. So 5 goes into that 5 times, and 5 goes into that. Five goes into that 1 time with 2 left over, so 14. Negative 5 pi over 4. 14, actually. Okay, another number that is not on the unit circle. Pi over 10. This is not normally listed on the unit circle either. So we're going to multiply by 180 divided by pi, because we want the pi's to cross out. And 10 goes into that 18 times. So it's 18 degrees. If you take pi, look at what this is saying. If you take pi and break it into, which is half the circle, and break it into 10 equal amounts, 1/10, 2/10, 3/10, 4/10, 5/10, and so forth, you would have 18 degrees for each of those 10 pieces. If you were talking about a degree value, or you would have pi divided by 10 is another way to discuss that same amount. Did I do crazy math? Let's see, 10 goes into there, 5, yes, that would be an 18, thank you. Crazy math. Oh, with 4 left over, and then 5 goes into 48 times. Yep, good job. So our next example, a record spins at 45 revolutions per minute. Through what angle does a point on the record spin in 1 minute? So that point is going around 45 times in 1 minute. So if we want our answer in degrees, we're going to say 45 does a full spin, which is 360. So we want to times 45 times 360. That would give us each time around is 360, and we do that 45 times. So we're talking 16,200 degrees. If we take our 2 pi, that's a full circle, that's your 360. And you're going to do that 45 times. That gives us 90 pi. Which pi is half a circle, right? So if you double your half a circle, you get 2 pi. So cutting this in half is your 45. So just trying to make some recognition of what that would mean. All right, for our last couple of pieces here, we're going to look at the degree and radian of these special angles. This should really be on a completely separate lesson, but we'll get them in there pretty quick. And then we'll spend some time going over this in the future. But this right here is a 30-degree angle. Well, first, before we talk about that, let's go around and talk about all the big angles. We're 90 when we go straight up. We're 180 when we're off to the side. We're 270 when we're straight down. And we're 360 when we come all the way back to the beginning. So if you cut the 180 in half, you get to the 90. If you cut 90 in half, what degree would we be at? That would be 45. So that would be like 45 degrees. 45, another 45 is 90, another 45 is 135, another 45 is 180, another 45 is 225, 270 is another 45, another 45 would be 315, and another 45 takes you all the way over to 360. Seem good? So now what we're going to do, we're going to break this up into another special right triangle. We have a 45 degree angle. This is going to be a 30 degree angle. So if this was a 30 degree angle, we can double that angle to get 60. 30 more takes you up to 90. So that's good math there. 30 more takes you to 120. 30 more is 150. 30 more is 180. 30 more is 210. 30 more is 240. 270. 300. 330. So we're just doing 30. Notice what the 30s did. The 30s jumped the 45 every time. Some people like to learn it by 15s and jumping the ones closest to the axis, because we don't talk about those. In radian measure, we know that pi is the same thing as 180. What's half the pi? How do we write that? What do we call that? Pi over 2. That's going to be your new way of talking about 90 degrees. What do you suspect 45 is going to be? If you take 180 and you break it into 2 equal pieces, that gives us pi over 2. If you take 45 and break it into, how many equal pieces would that be? How many pieces is that? 4. So this is pi over 4. This would be 2 pi over 4. 2 pi over 4 is pi over 2. This one would be 3 pi over 4. So we're counting by fourths. This would be 4 pi over 4. It would reduce down to pi. So what do you think this one would be? If that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, this would be 5 pi over 4. Oh, we haven't talked about this one down here yet. Would 1/4 get there? What else would get there? A half, 2 halves, 3 halves. So 3 pi over 2. You would be fine doing 6 pi over 4. 6 pi over 4 reduces to 3 pi over 2. It doesn't matter which one you use. It'll work. Now let's do 60. How many times does 60 fit into 180? Three times. So what's the radian at 60 degrees? Pi over 3. You're taking the pi and you're breaking it into 3 equal amounts. So it's pi over 3. What's 60 and 60? That takes you to 120. So what radian would 120 be? Two pi over 3. Because it's 2 of the 1/3. This would be 3 of the 1/3. Where would 4 pi over 3 fall in? $60 degrees takes you to 1/3. Another 60 degrees takes you to 2/3. Another 60 degrees takes you to 3 over 3. And another 60 degrees takes you to 4 pi over 3. Then you would have 5 pi over 3. So you're counting this by equal amounts. And then 6 pi over 3, which is 2 pi. The math has to match if it lands on the same coordinates. So what are we going to do with a third? Oops. What are we going to do with 30? How are we going to write the radian for 30? Okay, how did we write the radian for 45? How many times 45 went into 180? How did we write the radian for 90? How many 90s fit into 180? So 90 fits into 180 2 times. So you're dividing the pi by 2. You're dividing the pi by 4. So what are we dividing the pi by? How many times does 30 go into 180? 6 times. So this is pi over 6. 30 more is 2 pi over 6. That's the same thing. 3 pi over 6. Well, that's the same thing. 4 pi over 6. That's the same thing. Oh, here's a new one. What's this one going to be? 5 pi over 6. So you want to count. You need to actually count. That's how you do the unit circle. 1 over 6, 2, 3, 4, 5. This is 6 over 6, which reduces down to pi. So what's this one going to be? 7 pi over 6. 8 over 6 reduces. 9 over 6 reduces. 10 over 6 reduces. Oops, what's this one going to be? 11 pi over 6. And then 12 pi over 6. All right, now there's one spot we for some reason didn't fill in, and that's one right there. Can we figure out what number is going to fit in this slot? What radian is that? Count. You agree? So we see that it's in the middle, right? So that must be a 45 type angle. So that is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So that's 7 pi over 4. And we have listed all the radians that are on the unit circle. Oh my goodness.